Hi, I'm Mary. Welcome to another magical math moment. This video is designed for my Precal students who are learning about how to graph cosecant and secant functions. I'm going to show you what I think is the easiest way to do this, and hopefully it will make sense to you. Okay, so previously you've talked about how to graph sine and cosine. So if you can graph sine, you can graph cosecant. Let's take a look at this thing, shall we? So we know that sine is going to have a maximum function value of 1 and a minimum of -1. We have a start point, and then we're going to go out 1, 2, 3, 4 points. Hopefully we all remember that this is pi over 2. Let me think about how I want to do this. Yeah, this is fine down here. Pi over 2. This is going to be pi. This is going to be 3 pi over 2. And this is 2 pi at the end. Okay, so what I want to do here is just kind of sketch in a sine curve, and I'm going to do that using a dotted line because the sine curve is not part of the cosecant graph. Will it help you graph it? Absolutely. So here we go. I'm going to move my paper so I can try to make this presentable for you. If you're not sure what I'm doing with this sine graph, go and watch one of my previous videos and it will explain it to you. All right, so to deal with a cosecant function, what you're going to do is sketch in some vertical asymptotes when the sine function crosses the midline. So we're going to go ahead and go This is the line x equals 0. We're also going to do it over here. This is x equals pi. And then finally over here. X is 2 pi. All right. Once you have those asymptotes, those are going to help you and guide you as you sketch your cosecant function. So the cosecant piece is going to be here. And then it's going to kind of look like that. The other piece is going to be down here. So the minimum of the sine function is going to be the max in this area of the cosecant function. And they kind of do like a, oh, that's kind of bad. You get the idea though, okay? Try not to make them go straight down because then that's not a function, and that's kind of, it's tough for me to do this. I'm like banging into the thing that's holding my phone up. So hopefully it's not too bad. So the graph for cosecant is going to be the brown part. Sine is not part of it. Asymptotes are not part of it. They are important to the function because they serve as like a guide when you're doing these. Okay, so that's cosecant. Next, we get to look at secant. So again, its reciprocal friend is cosine. So we're gonna go ahead and just sketch in a cosine graph real quick. So we know we're going up to 1 and down to -1. We're going to go over 1, 2, 3, 4, just like the other, like with sine, pi over 2, pi, 3 pi over 2, and 2 pi. All right, we're going to go ahead and graph in our cosine graph. So we start up at 1, hit the midline, the minimum, midline, maximum. And again, if you're still not sure about sketching a cosine curve, go watch one of my other videos. I have 3 of them all about sine and cosine, including the basic ones, just the parent function, and then also some transformed ones. Hey, that's a nice looking cosine curve. All right, so the next thing you want to do, again, you're going to draw in your asymptotes when this function crosses the midline, or I should say when cosine crosses the midline, so at pi over 2 and 3 pi over 2. And now this is where we may argue a little. I know when I teach this class, I allow students to do their graph like this. Some teachers don't like it. So I'll show you my way, and then I'll show you how to fix it in case you have a teacher who doesn't like it this way. So with the secant, we're gonna start here and then kind of do like this guy. We're gonna do something similar over on this side where we kind of come up like so. And then we've got this point, and then we're gonna kind of go down through there like so. Some teachers don't like that because they want it to be more like the cosecant curve. So if you have a teacher or a professor who doesn't like this, You could always go over to negative pi over 2. And you could go ahead and do. And then look, this gives you a nice sine curve. And then when you sketch the rest of this thing, after you include an asymptote, x equals negative pi over 2, it's kind of like you have cosecant, right? So I don't really care for that too much. I think this looks kind of interesting. That's just me. I don't know. So check with your teacher or professor about how they would like you to graph secant. Again, as far as I'm concerned, I like this, but that's just me. Okay, let's talk about moving these things around a little. Here we have 2 cosecant of 2x. So the amplitude's going to be 2, just like sine and cosine, right? So that means instead of going up 1, we're going up 2. Remember that the period for these are also going to be 2 pi over b. In this case, 2 pi over 2, which is pi. So when we graph our sine curve to kind of serve as a guide, we're going to use these parameters to help us. Okay, so let's see. We're going to be going up 2 and then also down 2. We're going to be going out to pi. So depending on how you want this to look, I always like to just go out the 4 and then just kind of adjust my points. So if I'm at 0, this is pi. Halfway is going to be pi over 2. And dang, my intervals are not even, but we'll pretend. Half of a half is a fourth. So we've got pi over 4 here. 1/4, 2/4, 3/4 pi. Okay. Alrighty, the next thing I'm going to do is throw in my sine curve. So it starts always at the midline, goes up, midline, down, midline. So again, here we go. All right, once you have your sine sketch, now you're going to go ahead and drop your asymptote. So this is x is 0. Here's another one at x equals pi over 2. And finally down here at the end, x equals pi. Okay, let's go ahead and sketch in the rest of what we need to do. And remember, this brown part is the only thing really that is the cosecant function, okay? Try to make yours better than mine. I don't know what's going on here. It's late in the day or something. Hopefully yours looks nicer than whatever this is. All right, let's try one with secant. Ooh, look at this nonsense. This looks like fun. Our amplitude is still 1. The negative, remember, is going to flip this thing over the x-axis or reflect it over the x-axis if you want to be precise, and I guess we should be. Okay, this one's got a phase shift. So remember how we used to do this with the sine and cosine graphs. We're going to take whatever is in here and set it to 0. That's our usual start point. So after we add the pi on both sides, we know that this graph is going to start at pi. All right, the b value is 1, so the period is still 2 pi. That means this thing is going to end at pi plus 2 pi or 3 pi. This one at the end, remember, is a vertical shift. So there's a lot of things going on in this function. Okay. I feel like the last one wasn't so bad, and this one's throwing all kinds of weird stuff at us. All right, so let's see. We are going to be going over to pi. So 1 pi, I'll put that there. Pi. Okay. Then we're going to go over, here's 2 pi and 3 pi. Now remember, one cycle or one period of this thing is 2 pi. So it's starting at pi and going to 3 pi. That means I need to find the midpoint here and the midpoint here. So we know that halfway between 1 and 2 pi is going to be 1.5 or 3 pi over 2. Halfway between 2 and 3 is 2.5 or 5 pi over 2. I know that some of you absolutely love fractions, so enjoy that. All right, here's 1. Here's -1. So secant, we're going to start with a cosine sketched in. Oh, I almost forgot. We've got a vertical shift up of 1. Holy cow, that could have been a disaster. All right, so here we are at 1. Y equals 1. The amplitude then, we're going to go up to 2 and then also down to 0. Okay, so we don't really need that -1, but I'm using marker and I can't erase it, so it's there now. Okay, cosine normally starts high, but look, we've got a negative. So when I go out to pi, I don't start at the midline, I'm not starting high, I'm starting down here low. Then at my next interval, I'm going back to the midline. Then I go up here to 2, then I go back to the midline, and then back down to 0. And then I'm gonna do in my little thing like this. And here we go. And I don't know about you, but it looks kind of like a little mountain, right? Or maybe a normal curve, if any of you have taken psychology or stats. But yeah, that's kind of pretty. Okay, now we're gonna go to the midline. This time it's y = 1. And we're gonna go ahead and do our vertical asymptotes. So this is x = 3 pi over 2. And then over here, x is 5 pi over 2. We're gonna use the asymptotes to kind of guide our graph. Maybe I can make a really pretty one this time. Wishful thinking. And then we do the same thing down here, and then this guy over here. And there is your graph. So the negative is what kind of flips it. The phase shift is going over to pi. There's no change with the period, so we're still going out 2 pi to end at 3 pi. And we have that vertical shift at the end of 1. I hope that this video has been helpful for you. Don't get discouraged with these. I know they're weird looking, but really all you need to do is just remember what you know about sine and cosine graphs. I hope that this has been helpful. Please like, share, and subscribe, and let your classmates know about this channel as well so it can help them get through these things. And hope to see you again next time, sometime soon. Thanks for watching. Bye.